Hello YouTube, it's Jan Beta with this little thing here, which is an A501 RAM expansion for the Amiga 500. And yeah, many of these things are quite old, or yeah, all of these things are quite old. These are the original made by Commodore expansion cards, which have 512 megabytes of RAM on it, which gave the Amiga 500 with the 512 kilobyte that were in there as chip memory. It gave it a whopping 1 megabyte of RAM, which was quite a lot for the time actually, because we're talking like 1987. 1 megabyte was, yeah, it was a lot back then. So what these old things suffer from is they have these batteries for buffering the clock that's on there. That's probably this chip, I don't remember exactly. Yeah, there's a battery buffered clock, so you don't lose the time if this is powered off. Basically the same principle is still used in your basic PC. There's a little coin cell that buffers the clock and the BIOS settings and stuff like that. This big thing here is pretty old-fashioned, and it's yeah, these things tend to leak if they get too old. So that's what it did, and yeah, you can see here there's a lot of green stuff, and yeah, you can see it on this resistor here. That's the corrosion caused by the acid leaking out of the battery. And yeah, in most cases these boards are still usable if you clean them up. And yeah, I'm basically gonna desolder the battery. That's the first thing you're gonna do. This is working without the battery. If it's working at all, I don't know yet, because it was in the eBay haul of Amiga stuff I unpacked in a previous video. I will link that in here in the corner. These Amiga A501s also came in these yeah, it's like a tin box that you could bend apart. Sometimes they are soldered. This one was glued together, I think, and yeah. So I pried this open and removed it because it's basically RF shielding, not to shield this from outside RF, but to shield the outside world from the RF that is coming from this machine, and to fulfill the compliance standards of the 1980s, which are a bit different today. And I guess this would be, it's okay to use this nowadays, because there's a lot of RF going on anyway, because of all the Wi-Fi and stuff like that. There's so much electrical smog out there. Yeah, what we're gonna do, I'm gonna desolder this battery because it's broken anyway. We're gonna determine if all the components still work and check them with the multimeter, the ones we can check. And we're gonna try to remove all the corrosion as good as we can with the help of some isopropanol alcohol and a toothbrush and some patience. So let's get it on. So here we go. The iron is heated up, and let's see. I think these are the contacts, and these are the contacts. This is one side of the battery, and these two are the other side of the battery, so we have to desolder these. I'm gonna use some new fresh solder here to put some flux on there to make it easier to desolder. Then I'm gonna bend this out of the way, I guess. So here we go. And I'm gonna use some solder wick to quickly wipe this off, I guess. You could also use any other device here, I guess. But yeah, I'm basically too lazy to get out the desoldering station, which I have, and I could link in the video. Yeah, I'd probably link in the video in the info section. So what I'm going to use now is the solder wick, which works quite well. And yeah, it just sucks out the solder. And should be able to remove this with some wiggling here. Yeah. And there we go. That's our very dead and leaked battery. You can see that it has leaked a bit underneath here and broken this trace altogether. But we don't need the battery, so I hope everything's gonna be alright. We have to see if there's something gotten under this chip here, I guess. But otherwise this board seems to be in an okay state. So let's see if we can clean off some of the acid residue there. So here's my favorite part again, the isopropanol alcohol part. So let's spray this generously. And I get out my toothbrush. You've probably seen me clean stuff, so I'm just gonna do it here. Let's see if we can get it all off. You actually have to rub quite a bit to get the corrosion off there. Not that easy, but it eventually goes away, I guess. Or most of it, at least. The problem is if you leave some of the green stuff is it's copper that's oxidized, copper oxide that is of a blue color, and together with the red yellowish color of the copper it gives a little green tone, a nice little one. So that's what's looking green there. Maybe we'll have to remove this little capacitor here. That looks pretty bad, I guess. Maybe we'll have to replace that. So let's not forget the back side here. So yeah, this one capacitor here, R912. It looks pretty bad. It's quite green, I think. Yeah, it probably will still work, and I try to clean it off, but I think I'll replace it. So yeah, some of these capacitors here also look quite bad. But otherwise, this seems okay. The traces seem okay. So, yeah. So, here's one trace that has a little corrosion there. Let's check if there's continuity with the multimeter. So, here's the multimeter continuity testing. So there should be a connection from this point here, to this point, which there is still. Okay, and there should be a connection from this here to this, which there is, and there should be a connection from this one to this one, this one to this one, this one to this one. Yeah, okay, it all looks worse than it is, I guess. Let's check the little resistor there. It's a 10K, I guess. I think I just replaced this just for the sake of being sure, because this corrosion sometimes it eats right into the component and then damages the component, and yeah, you probably don't want a shorted resistor in this, so yeah, otherwise let's see, is there any diode has a high resistance, which is as expected. The other one has a high resistance. Capacitor should go up. Yes. The capacitors always, as they load, the resistance rises, so you can easily check those. It's just a quick test if they're still alive, I would say. If the resistance goes up, because for testing the resistance, the multimeter sends a little current through the probes and through the test leads, and you can basically, the capacitors load up through this little current, and their resistance rises, so you can check if they are still working at all. So yeah, these are all alright, I guess. The other ones here on top here, they weren't in the acid bath, I would say. Yeah, and this is brown, black, yellow. The red means 1, the black means 0, the yellow, which you can barely see on camera, but it's there, means 10K, it's the multiplier. And there's a gold ring, which means 5% tolerance of the resistance. So it's within spec if it doesn't vary by more than 5%. So yeah, let's desolder this and insert a new one, I guess. So let's take a new 10K one and insert it there quite crudely. So there we go. Yeah, basically this could be working if all the ICs and the RAM chips on here are working, which I suspect because these are not as prone to failure as the Commodore 64 ones, for example. Maybe I should fix this anyway. Now that I look at it, this seems to be scraped away deliberately, because on the other side of the board there's this bodgy looking resistor connected over there. Probably is some sort of bleeding resistor for the batteries, so I don't really know what it's for. Anyway, let's test this out in a known working Amiga and hope that neither this nor the Amiga blows up while doing so. So this is a working Amiga 500. It was the one, if you follow me on Twitter, you probably read there that I had to replace the keyboard in this. That's why the machine itself looks a bit yellower than the keyboard. But it's fully working now, and that's worth something, I guess. Yeah, and these Amigas, they have this little trapdoor on the back where there is, let me use the screwdriver. There is a RAM expansion in there. In this case, this little one here, which I have. And yeah, this works basically. It's a working one. I already desoldered the battery on this one and marked where the positive and the negative rails are, so I can replace it with a coin cell at some point to have a battery backed up clock again. But now we're gonna test the RAM expansion we just cleaned. So let's see. Should go in like this. Let's close it up for convenience. And let's turn it around, connect some power. So, okay, as you can see, it says the battery backed up clock is not found. Yeah, that's normal, I guess, because we just removed the battery, so it won't be able to find the clock. So there we are at the workbench screen. Let me connect the mouse, I guess, so we can see. I'm sorry that this TV capturing stick, the dimensions are not right and you can't see the... What I wanted to do is to show you the top row of the screen there, the workbench title bar. So there you could see how much memory this displays. So let's look for the mouse. Where is it? Mousy, mousy. There we are. And no, it's not working. It's not working. It's displaying 306. So it's basically the Amiga without the expansion. So I guess there's something wrong with this still. Maybe we should investigate further. Okay, so the first attempt at repairing this didn't work. And through the magic of filmmaking, it's quite a few days later now, and I looked at this again and again, and I downloaded some schematics for this and looked into forums. And yeah, then one evening I looked at a really nice close-up picture of this. I especially looked at the solder joints on this connector here. And yeah, suddenly I saw this here. And as you can see on the picture I downloaded off the internet, there's a connection there to the, I think it's the positive power rail here. Yeah, so I realized that someone hacked in a switch here to turn this off. And if there's no switch connected between this pin and probably this pin, or this pin maybe, I don't know, it's very hard to see where it was connected, but basically it's this pin, this pin, this pin, and the pin next to it, and this pin, that are supposed to be connected together to this rail here. And yeah, if one of them is not connected, then this is basically not turning on and the Amiga doesn't see it. So what I'm going to do is to solder a little wire, or a little wire between these two pins, I guess, to make a connection there and then check again if it works. And yeah, I think it will. So let's see. So doing this very thoroughly and cleaning it up. So there's the connection. Then we take a little like so, maybe. I could also easily hack in a new switch, but I won't do that because most of the times you don't need a switch, I guess. So there we go. Should probably add some more solder. There's our connection. And yeah, let's check if this really is connected. Probably can hear that. So let's see. So this should be connected to this one here, which it is, and to this one, and this should also be connected to this one, and the two of those should be connected together. and they should not be connected to any of the surrounding pins. So yeah, this seems to have worked. Now let's see if this works again in an Amiga. Oh, what I also did and didn't film is to make this little botch connection here, which is replacing the trace here, which doesn't have anything to do with the memory expansion, but with the clock. So that wouldn't be a game breaker for the RAM expansion, I guess, but I redid this connection anyway, because at a later point I want to give this a new battery and try if it works off a coin cell here. So as you can see, the setup has changed quite a bit, mainly because I got this nice old school monitor, which is a Philips 8833 Mark II, which is a great monitor for the Commodore 64 and the Amiga. Yeah, it's basically an old CRT from the 90s. So exactly the kind of monitor these things were made for, because there weren't any flat screens back then, at least not for the home computing market, I guess. So yeah, let's turn this all on and see if the Amiga sees the RAM expansion. And it seems to see the clock. It's not buffered, so it's showing totally, the time is totally off. It's 1978, which it clearly isn't. But it sees the clock, which is a good sign, I guess. Let's see how much memory it's gonna display. So, whoa, this takes quite a while. Yeah, let's have a look at how much memory this has. 878,912 kilobytes, which is the 1 megabyte it has now, minus the memory it needs for loading up the workbench, which is quite a bit. This RAM expansion works again, so this repair was successful. Yeah, if you like this, give it a little thumbs up, which helps a lot. And subscribe to my channel if you like. There's going to be a lot more on the Amiga and on retro computers in general, especially the Commodore 64. There's going to be a lot of other electronics stuff and tinkering and yeah, basically everything related to repairs and tinkering with electronics. So yeah, stay tuned for more. I would be very happy to see you again on this channel. I'm Jan Beta. Thanks for watching. See you next time. Bye!